Hello students of grade 10. Today we are going to discuss about an interesting and important topic from the chapter electricity. It's nothing but Ohm's law. Whenever you are studying a new law, we have to ask three questions to the law. The first one, what? Second one, why? Third one, where? Let us discuss what is in this law, why this law, and where it should be applicable. So before starting this law, I want to inform you that we have to know the two important terms related to electricity. First one is potential difference, second one is current. These two terms is very necessary to get the answer for the first question, why this law. Let us discuss the first term, potential difference. Here the term itself is the meaning is that it's a difference. So what is the difference? A positive and a negative is having a difference is there. Here you have a positive as well as a negative. Take an example of a cell, which you can see that a positive terminal as well as a negative terminal. So between these two a difference is there, that is a potential difference. The second term is current. So what is current? We know the structure of atom. In there you can see that the central part is the nucleus is there. Proton and neutrons are resides inside the nucleus. There are a lot of free electrons are revolving around the nucleus. Then these free electrons can move easily. So these electrons can flow out. This movement of electron is called electricity, or simply we are calling it as current electricity. So before you are coming to this law, you need these two terms. One is potential difference and its unit is volt. Second one is current and its unit is ampere. So these two terms is necessary to understand this law. Now let's go to the first question, why this law? You are studying a lot of laws from the different chapters, especially in science itself. So what make this law differ from the other law? That is, here we have two terms, one is voltage, second one is current. So this law is giving the relation between voltage and current. Remember, Ohm's law is giving the relation between voltage and current. Okay, now we got a relation for the first one. Now we got an answer for the first question is that why this law? This law is giving the connection between voltage or the potential difference and current. Let us ask the second question, what is in this law? So let us go for the statement. At a constant temperature, the potential difference directly proportional to current. I am repeating once again, at a constant temperature should be constant. Potential difference directly proportional to current, that is a statement. So what is in this law? Potential difference is directly proportional to current, that is a statement. So we got the answer for the second question. What is in this law? This law is giving the relation between voltage and current, and voltage is directly proportional to current, that is a in this law. Let us go for the third one, where it is applicable. Okay, let's elaborate the second point. What is in this law? You take two cell. One is a 1.5 volt cell, second one is 3 volt cell. If you connect a bulb to 1.5 volt cell and a 3 volt cell, out of these two, which cell if you provide to the bulb will glow much? Obviously you will get the answer is that if you connect it to a 3 volt cell. Why? Because we are saying it has more potential difference. So there is a relation. Once the potential difference is increasing, something is happening on the other side. What is that? Yes, according to the law, we know that when the potential difference increases, current also increases. Take an example of your water tank. You keep your water tank on the top. It's very much height is there. Then you will get the flow of water will be there. How much will be the force of that water? It will be very high. When you reduce the height, that flow will be decreases. Then you reduce the height, again the flow will be decreases. Then again you just keep the water tank on the ground. Will you get water through your pipe? No, because there is no difference in the height. So just think in reverse. When you are increasing the height, what happens for the flow of water? Its speed is increasing. While you are decreasing the height, what happens for the flow of water? Its speed is decreasing. So while increasing the height, speed is increasing. While decreasing the height, speed is decreasing. So there is a relation. What is that? When the height increases, flow of water also will be increases. Similarly, when the potential difference increases, current flow also increases. That's why the 3 volt cell is better than 1.5 volt cell. Okay, let's ask the third question, where it is applicable. Okay, now I am coming to the second point. Voltage is directly proportional to current. So V proportional to I. When you are changing the proportionality into equality, is a universal law is there, you have to add a constant. So in this manner, we are changing the potential difference. V is proportional to I, that and proportionality I am changing into equality. I am going to add a constant, that is nothing but resistance. So the equation will change into V equal to R into I, where R is the constant and its name is resistance. R is resistance. So your equation will be changed to V is equal to R into I. Then according to the question, you can change the equation appropriately. You can change I is equal to V by R or R is equal to V by I. That is according to the requirement. You can change the equation appropriately. Okay, let us discuss more about the resistance. So actually what is meant by resistance? That is the opposition offered by the material against the flow of current. If you take different material, just take an example of copper wire, or other material is aluminum wire, and other one is a gold wire, where the electricity will flow very smoothly. That is according to the opposition offered by the material. If which material is offering less resistance, that will be the best conductor. Which is material has less resistance, that will be the best conductor. So accordingly you can classify the material into conductor as well as insulator. Then what will be conductor? The material which has less resistance will be the conductor. The material which have high resistance, that will be the insulator. So when the current is flowing through the material or the conductor, it will try to oppose the flow of current. Then that is offering an opposition to the flow of current, that we are termed it as resistance. We are calling it as resistance. Resistance is a new term. It has a unit. Unit is nothing but ohm. O-H-M is the unit of resistance. Okay, where it is applicable? Let us imagine a circuit. I connected a 100 ohm resistance with a 9 volt cell. It has a potential difference. The cell has a potential difference, that is 9 volt. I connected a 100 ohm resistor in there. Obviously you can see that from the positive side to negative side the current will flow. From the terminal positive towards terminal negative, the current will flow. That is a conventional direction of the current. It will also pass through the resistance, and resistance will be offered a resistance against the flow of current. Then we can calculate how much current will flow through this circuit. So we have an equation I is equal to V by R. So in this, potential difference is 9 volt and the resistance is 100 ohm. Then according to the equation I is equal to V by R, you will get I is equal to 9 divided by 100. Then your answer will be 0.09 ampere current is the current flow in this circuit. So we have applied Ohm's law in this circuit. So let us revise the 3 points. Why this law? Because this law is giving the connection between voltage and current. Second question, what is in this law? At a constant temperature, potential difference directly proportional to current flowing through it. So V is equal to I into R. Finally we are reaching to the when the voltage increases, current also increases, and the voltage decreases, current also decreases. That is a second question. Answer for the second question. Third question, where it is applicable. We have applied in the circuit. Accordingly, we could calculate what is the current through it. We will meet in next class with another interesting topic. Until then, take care. Bye.